All right, well, let's get started. For the presentation, protecting Ontario workers from heat stress and heat-related illness. Although if you were to take a look outside today, and well, pretty much for this entire year so far, it hasn't been too hot, but we know that that's going to change fairly quickly. In fact, they're expecting some warmer weather starting next week. And with climate change, we're going to expect that Ontario workers are going to be exposed to heat stress more frequently as the years progress as well. So it's something we definitely need to address. A little bit about myself, the presenter. My name is Ryan Mallard. I'm an occupational hygienist and the operations manager with the Occupational Health and Safety Group in our Pinchin's Mississauga head office. I've been with Pinchin for almost 23 years now, and I've been a hygienist for over 25 years as well. So lots of experience doing various occupational hygiene and health and safety related activities as well. My contact information is up there, phone number and cell phone number as well. If you needed to reach out to me, feel free to contact me outside of the presentation. But again, if you do have questions during the presentation as we go on, feel free to put your question in the Q&A section, and I will try and answer those as best as I can. Um, yeah, so let's talk about what we want to talk about today. The other thing I should mention too is we do have an hour and a half blocked off for this. I don't anticipate we're going to take the full time, but I wanted to make sure I've got enough time to allow for questions that may come up as well. So that's why we scheduled this for an hour and a half. So for today's agenda, we're going to be talking about the effects of heat stress. So in other words, why do we care about protecting the workers? What is the impact it's going to have on the workers? We're going to talk about the regulatory information, what the Ministry of Labor uh, says about heat stress and how we should be protecting our workers. Included in that is I'm going to go over in detail about the regulatory impact analysis that the Ministry of Labor, Immigration, Training and Skills Development, I'm going to call the Ministry of Labor for short, but just be aware that that's their full name. I'll talk about Bill 222 or 222, which talked about heat stress, what was included in that. I'll talk about the how we evaluate heat stress in our workplace. The ACGH, or American Conference of Governmental Industrial Hygienists, threshold limit values are the most common way we evaluate heat stress in the workplace, but there are other methods available, including the OCAL, Occupational Health Clinic for Ontario Workers. They have a method that's based on Humidex values, which can be useful as well. If you know that heat stress is a concern at your workplace, having a heat stress program is something that would be recommended. So I'll talk about what should be included in that program. We'll talk about controls or what we have to do to put in place to protect workers. And then we'll have a question period at the end as well. But obviously, if you have questions as we're moving through this presentation, just drop them in the Q&A spot. Before we begin, I just wanted to get an idea of where the concerns about heat stress are at your facility. So I've got a polling question here. I was hoping that I could get people to answer. Uh, Basically, looking at where you have heat stress concerns at your house, at your facility. Is it just during hot months? Is it because you work around hot pieces of equipment? Are you inside workers, but during heat waves? Or maybe there's more than one. Maybe heat stress isn't a concern, but you just want to get some knowledge about what heat stress is and how to protect your workers. Okay, I see most people have responded here. So it looks like it's pretty evenly split. We've got three of you saying that there's work outside in the hot months, the same number of people saying working around hot process equipment, same number of people saying inside during the hot, and then one person saying more than the above as well. So uh, bit of a mix there in terms of where heat stress concern is at your facility, which is great. Hopefully this presentation will cover all the different aspects that of heat stress concern at your facility. So what we want to talk about is the impact of heat stress or how heat stress is going to impact the workers. Heat stress is really a combination of different things. It's really the net heat load to which a worker may be exposed. And heat can be generated from metabolic heat. So as the workers are working, their body generates heat, and that's going to impact their bodies. There can be environmental factors, which include things like air temperature, humidity levels, and clothing. Some clothing can inhibit how your body cools itself down, and those are things that we have to take into account as well. So heat stress arises when the body has difficulty regulating its own internal temperature. And heat strain is the overall physiological response resulting from heat stress, or how our body reacts to that heat stress. So if we want to control heat stress in order to prevent the heat strain of the worker, we really want to control the worker's body core temperature from exceeding 37 degrees Celsius. That's your standard core body temperature. And if the body's core body temperature varies by a degree or more, it can reduce the body's ability to cope with that heat stress, and you can develop a heat stress illness. Typically, when we're talking about heat stress illness, there's five illnesses we typically cover. Those being heat rash. That's where the worker may see red bumps on their skin. It's usually very itchy. And you see that in very hot, humid environments, quite often in dirty, dusty environments as well, because it's a result of plugged sweat glands. So the sweat glands can no longer sweat. They develop these red bumps and become very itchy. Um, for treatment for someone that has a heat rash, you're typically going to get them to change into clean clothing. You're going to have them avoid hot environments, rinse their skin with cool, clean water, maybe even wash the skin as well to help remove those plugged glands. And prevention is to make sure that the worker is washing regularly, keeping their skin dry and clean as well. A more serious form of heat-related illness could be heat cramps. This is where a worker develops muscle pain. Typically, you see that in the larger muscles, so the legs, the arms, the stomach muscles are most common, and it's caused by a salt imbalance. So as you sweat, you're not only sweating water, but you're sweating salt out as well. And if you lose too much salt, it can affect the way the muscles work, and you can get cramps. Now, sometimes the workers will develop cramps while they're working because they're sweating so much and losing these electrolytes and salt from their blood. But sometimes they may not even notice these heat cramps till after work. So they've packed up for the day, they're gone home. As their muscles cool down, then they start to get the cramps in their muscles. Treatment for heat cramps is to move the worker to a cool area, loosen their clothing, gently massage the affected muscles, have them drink water that's slightly salted to help replenish those electrolyte loss. So things like Gatorade or Squencher or those type of athletic drinks are very helpful. And prevention is to reduce activity, reduce heat exposure, drink lots of fluids, including electrolytes as well, and check on coworkers as well. We often find with heat stress that your coworkers may be able to identify the symptoms of heat stress in their coworkers better than you can identify the symptoms in yourself. Sometimes the heat stress will prevent you from noticing your own body symptoms as well. So working with coworkers or in a buddy system is a good practice in hot environments as well. Another more serious form of heat-related illness could be fainting. So this is where a person has had a fluid loss, not enough water intake, so they're dehydrated, and they may have cool, moist skin and a weak pulse. This is a very serious incident. Loss of consciousness is considered a critical injury by the Ministry of Labor, so they would also need to be notified if you had a worker fainting due to heat-related illness. Medical attention for treatment for this would be required medical attention. So you're going to want to have them see medical provider. You're going to move them to a cool area, have them lie down. If they're awake, have them sip some cool water. And prevention for fainting and the other ones that I'm going to talk about is really reduce activity, reduce heat exposure, drink fluids, um, have the coworkers check on each other. And for fainting, also standing in one place for too long can also make you more susceptible to fainting. So if you're thinking of our roadside work where you've got someone standing there with a stop sign or slow sign, they could be at risk from standing in one area for too long for fainting as well. As we move up to more serious conditions, one would be heat exhaustion. So this is where the body can't cope with the increased heat, and you generally see very heavy sweating, but cool, moist skin, and the body temperature will rise above 38 degrees, which is a concern. Individuals suffering from heat exhaustion will typically have a weak pulse. They'll have low blood pressure. They may feel tired and weak. They may feel nauseous and even experience vomiting. They'll feel very thirsty, panting. They may be out of breath and even have blurred vision. So this is a serious concern. And if you have workers with heat exhaustion, you want to get medical attention as well. But immediately you'd want to move that person to a cool area, loosen their clothing, have them drink water, spray them with cool water as well to help them cool down. And prevention, again, is similar. Reduce the activity, reduce heat exposure, drink fluids, and have coworkers check on each other. Now, heat stroke is a very serious heat illness. This is where your body's cooling system breaks down and the internal core temperature typically exceeds 40 degrees. So it's basically like having a high fever. And if condition prolongs, you can be at risk for damaging your internal organs as well. There's two types of heat stroke. There's the classic heat stroke where the person will actually lose the ability to sweat and they're not very physically active when they're ill. So they may feel nauseous, they may not be feeling well, and you go up to them and you'd think, well, you're working in a very hot environment, but they're not sweating at all, or they've stopped sweating. That's a very serious concern. There's also an exertional heat stress where the person will be sweating profusely. They may still be active, but they may be still suffering from heat stroke because their core body temperature has gone above 40 degrees. These individuals usually express fast pulse. They may have a headache or be dizzy. They may be passing out, feel weakness or confused or acting strangely because of the high temperatures. They usually have hot, dry, red skin for a classic heat stroke or profusely sweating for exertional heat stroke. This again is a very serious condition. You'd want to call an ambulance if you had someone with a heat stroke because of the temperature so high. You'd want to remove excess clothing, have them drink water if they're conscious, spray them with cool water. And the prevention is similar. Reduce activity, reduce heat exposure, drink fluids, check on coworkers. And when you're working in very hot environments too, uh, you may have to drink water even though you don't feel thirsty. By the time you do feel thirsty, that's usually a sign that you're already dehydrated and you're already in need of drinking fluids. So we know now that heat stress can cause some injuries and be of a concern for exposures. So what does the Ministry of Labor or what do the regulations say about what we have to do in terms of heat stress? So that leads me to my second poll question, uh, which is um, where do you think the control of heat stress is covered in the Ontario Health and Safety legislation? Heat stress regulation, Occupational Health and Safety Act General Duty Clause, industrial establishments, construction project regulation, um, none of the above, or you're not really sure. And that's fine to say you're not sure. All right. Some answers rolling in here. Okay. Answers are slowing down. Last chance to get your answer in. Okay, so we had a mix here. Some people think there's heat stress regulations. Some say it's the general duty clause, and we've got some individuals thinking it's the uh, industrial establishment regulation. So first, let's talk about the heat impact in Ontario. So between 2006 and 2015, there have been 350 lost time claims related to heat exhaustion for construction workers alone. So this doesn't cover other industries. This doesn't cover manufacturing, healthcare, education, farming, nothing like that. This is just purely construction. So you can see heat stress can have an impact on workers in Ontario. Now, I'm not really going to go into much detail about it, but if you have workers working outside and they're exposed to sunlight, there's also a cancer risk that must be taken into account. I'm really focusing more on the heat aspect of it. But currently, heat stress is not directly addressed in any regulation. So they don't talk about it specifically. So we would fall back on the general duty clause of the Occupational Health and Safety Act, which states that employers must take every precaution reasonable in the circumstance for the protection of a worker. So just because we don't have a specific regulation that addresses heat stress, or because heat stress is not mentioned in the other regulations, doesn't mean we have to ignore it. We know or ought to know that heat stress can be a concern for workers. And if we have workers working around hot equipment or outside or during heat waves, we still need to protect those workers. Now, however, in August 2023, the Ministry of Labor did conduct a regulatory impact analysis to assess the benefit and cost of a heat stress regulation. Public consultation closed fairly quickly, September 18th, 2023, which to me thought, well, maybe they're going to push a heat stress regulation through, but between then and now, it's been almost 2 years now. There was an election which delayed things. So it's currently unknown when or if a heat stress regulation will be promulgated in Ontario. So let's go over that regulatory impact analysis. Um, the regulatory impact analysis did have some important points in there where if they were to develop a heat stress regulation, I would anticipate a lot of these points will become part of the regulation. So they did state that employers are to protect workers from exposure to thermal conditions that may result in heat-related illness or the worker's core body temperature exceeding 38 degrees. Employers also have to identify and implement measures and controls to control heat stress based on the hierarchy of controls. Hierarchy of controls are, first of all, if you can eliminate or substitute the hazard. We may not be able to eliminate the heat if it's a heat wave or if you're working around hot pieces of equipment, so may or may not be an option. There's engineering controls, so something you may put in place to prevent the heat from reaching the worker, like barriers and shields, to administrative controls, which typically when we're talking about heat stress involves providing additional breaks to the workers, but they can also include things like training, so the workers have the knowledge of what heat stress is and what signs and symptoms to look for. And finally, the last resort would be personal protective equipment. So wearing something that protects the worker from heat stress. Employers are also to provide workers information and instructions on recognizing the signs and symptoms of heat-related illness and measures to protect themselves. So in other words, if you have workers that are exposed to heat, you should be providing them with some training to provide them with information on how to protect themselves and what to look for. There were some major points in the regulatory impact that I've summarized here. So number one, there's the duty to protect the worker's core body temperature from exceeding 38 degrees. That's ultimately what we're trying to do. You have to have compliance with exposure limits for light, moderate, heavy, or very heavy workloads. So the ministry recognizes that someone that's sitting at a desk, maybe pressing buttons outside in the heat, might have a higher or a lower risk than someone who's shoveling sand, as an example, in the same hot environment. So you have to take into consideration what the worker is doing as well. You have to allow for methods other than the ACJH to assess exposures if methods are in accordance with recognized industrial hygiene methods and provide at least equal protection. So that would suggest that the ACJH threshold limit values are going to be incorporated into the heat stress regulation, but they will allow for other methods that are available. And I will discuss ACJH and OCAL methods as two methods that could be used. If physiological monitoring is conducted, it must be conducted by and supervised by a qualified person, so someone with the knowledge, training, and experience to do that. Physiological monitoring could be things like taking a worker's core body temperature or measuring their heart rate, as an example. Engineering controls are to be used to control exposures. There are some exceptions. So the exceptions they listed were if the work is done outdoors. Although I would argue if you have workers outdoors, there are still opportunities for engineering controls. For example, you could put up shade so the workers would work in the shade instead of in direct sunlight, or they could at least take their breaks in a shaded area instead of in direct sunlight as well. Other exceptions would be if you're working indoors and you already have engineering controls in place, but there's a temporarily high level of heat. So for example, there's a heat wave and the engineering controls can't cope with that heat wave. Or if you're working around an oven, you've got engineering controls to control the temperature, but when you open the oven, there's a blast of hot air. You may not be able to use engineering controls to control those sort of temporary heat waves. And the third one being if you're working indoors, but it's not reasonable or practical to control heat through engineering controls. So their ministry is not going to expect that you're going to spend $10 million to air condition an area because the area gets warm every once in a while. That's not reasonable or practical. And if there are additional controls beyond engineering controls, for example, you're using administrative controls like extra brakes or personal protective equipment like cooling vests, then those additional controls must be in consultation with your joint health and safety committee or health and safety rep. They must include administrative controls such as brakes, adjusting the time of day that you work. They can include personal protective equipment, but they also have to be in writing. So you have to have this in writing, which would suggest that the ministry's expectation is that you're going to have a program or a plan in place for heat, whether it be a hot weather plan or a heat stress program in place. Some other points are that cool, potable drinking water or hydrating fluid like Gatorade or Squencher is to be provided by the employer and close to the work area. So you can't provide it for the workers, but they have to walk half an hour to get to it. It has to be in the work area, especially considering that you may want workers to be drinking frequently. Like, for example, every 20 minutes, you may want them to have a cup of water. So it needs to be near where their work area is. Workers must be provided info where thermal conditions are likely to pose a hazard, so that suggests that worker training will be involved. And you must inform workers if there's an Environment Canada and Climate Change Canada heat warning that there's an increased risk of heat-related illness and the importance of staying hydrated, drinking fluids, and taking breaks according to a work rest schedule. So that's it. More important if you have workers that are working outdoors that may be impacted by heat waves. The information that you have to provide the workers include the measures and procedures that are implemented to protect them, including engineering controls, the importance of staying hydrated, taking breaks that are identified in a work rest schedule that you've developed, the early warning signs and symptoms of heat strain, illness, and precautions and prevention methods, as well as steps that the worker will immediately take if they suspect that they are experiencing heat-related illness. So you don't want the workers to say, I think I'm getting heat exhaustion, but I'm just going to continue working. You want to inform them. You want to stop work, notify your supervisor, and then go through the first aid procedures then. So it's not confirmed if when a heat stress regulation will come in effect or what will necessarily be covered by it. I think the regulatory impact that we just went through will give us some clues as to maybe in there. But it is assumed that the ACGH TLB and provisions for other evaluation methods will be included. It's likely to include provisions for worker training, written programs or plans, measurement of workplace conditions, so evaluation of the workplace. You will need to take account adjustments for clothing, the assessment of the work rates, light, medium, heavy, or very heavy. You have to take into consideration if there's radiant heat sources of heat. Because if you have a worker working next to a very hot oven or process equipment, they're going to be exposed to the heat from that equipment. Likewise, if they're working outdoors, the sun is a source of radiant heat as well. You have to provide the workers with drinking water, and there might be some other provisions in there as well. So this is what we've sort of gleaned from this regulatory impact analysis as to what may be in a regulation. Now, however, there was a private member's bill that talked about heat stress regulation that went through its first reading in November 7th, 2024. So it's unknown if it's going to have a second or third reading, but in order for a bill to become promulgated into law, it has to have three readings and then before it goes to the royal assent. And it typically takes about 12 months after the royal assent to come into force. So I wouldn't expect that we're going to see heat stress regulation this year. We may get the royal assent quickly if they went through all the readings, but we're still looking at probably a year after royal assent before it's actually made into a regulation and put out there. However, there were some key points in this bill that included a requirement to eliminate hazardous levels of heat stress through engineering controls. So again, they talk about isolation, isolating the work area from the worker, shielding, exhausting hot air, insulation of hot surfaces, or climate control technology like air conditioning as examples of engineering controls. They talk about limiting exposure to hazardous levels of heat stress through a hierarchy of controls. Again, that being elimination, substitution, engineering controls, administrative controls, and finally personal protective equipment. And provide at the employer's expense additional breaks as necessary and personal protective equipment. And personal protective equipment can include like water-cooled garments. I've seen vests that have ice packs in them, air-conditioned vests. I've seen hard hats with fans in them as an example of ways to help control heat stress. Some other points in Bill 222 that the employer must develop and implement a heat stress and protection policy and program in consultation with your health and safety rep or joint health and safety committee that is reviewed no less than every 12 months. So you have to have something written which explains how you're going to manage heat stress and what you're going to do. And then you have to review that every 12 months as well to make sure that is our program working? And if not, let's adjust that to make sure that it works in the future. And you have to have the Joint Health and Safety Committee buy-in on that as well. The employer is to conduct heat stress assessments as often as necessary to determine if a worker is or may be exposed to conditions to cause heat stress. And this is because if you take your measurements at 9 in the morning, it may not reflect what a worker is exposed to at 2 in the afternoon when the sun and the temperature is at the peak. So you have to make sure you're assessing for the conditions that the worker is exposed to. The employer is to provide the Health and Safety Committee and Joint Health and Safety Committee with the results of every heat stress assessment. So if you're out there taking measurements to assess the impact of heat stress on a worker, you have to provide those results to your Health and Safety Committee or rep. And every employer is to provide workers with access to cool drinking water or an alternative like the fluid replacement close to every work area as well. So if you have multiple work areas, you may need multiple spots where you're providing workers drinking fluids. Now, there are also some training requirements that the employers must provide because as you may know, one of the rights of Ontario workers is the right to know about the hazards in the workplace. So this training would cover off that worker right, including the signs and symptoms of heat-related illness, emergency response procedures, and their rights. So they have the right to refuse unsafe work. That's another right that the workers have. So if they feel that heat stress is creating an unsafe work condition, they have the right to refuse work and go through that process. The other right of workers is the right to participate. So that's why the Joint Health and Safety Committee is involved because workers' participation is usually done through your Health and Safety Committee or a joint or health and safety representative, depending on the size of your organization. Supervisors must also be trained on monitoring, so the evaluation of the heat stress and reporting heat conditions and environmental forecasts as well. They must recognize the signs and symptoms of heat-related illness so that they can understand if their workers under their supervision are experiencing heat stress and the protocols to responding to heat-related illness as well. So the supervisors need to know, first of all, if they see a worker to know, are they experiencing a heat-related illness? And if so, what do we need to do to protect them? And best practices for controlling heat exposure to heat stress would also be included in that training. So we've talked about why we want to protect workers from heat stress or what damage it can do. We've talked about what we think may be in regulation based on the regulatory impact evaluation and Bill 222. But what about assessing? So how do we evaluate heat stress in the workplace? So another poll question here. Just wondering if anyone out there has actually conducted heat stress monitoring. So maybe you haven't, or maybe you've used ACGH or OCOW or both, or maybe you've used another method. So let me know if you have. Okay, last chance to get your answer in. So it looks like we've got a mix of people who have not done heat stress evaluation. So a lot of this information will be new to you, and some people that have used the OCOW Humidex based message, which I'll talk briefly about as well. So The first method we'll talk about is the ACGH TLV, or American Conference of Governmental Industrial Hygienists Threshold Limit Value. ACGH is a US-based not-for-profit organization that looks at occupational hygiene and develops exposure limits and control methods as well. So every year they put out a TLV booklet, which has various different exposure limits. And if you work as a federally regulated workplace, those exposure limits are your regulatory limits. And in Ontario, a vast majority of the exposure limits we have been adopted from the ACGH TLV. And they include exposure limits for not only chemical agents, but also things like lasers, UV light, heat and cold, uh, ergonomic hazards, radiation. So they have exposure limits and guidelines for many different physical and chemical agents out there. So we'll talk about the heat stress one here. And ACGH TLV for heat stress is really the gold standard for evaluating heat stress globally, really. It considers environmental heat, so it takes into consideration not only air temperature, but humidity and wind speed. If you've got you're outside on a hot day and there's no wind, it feels a lot hotter than the same temperature, but with wind that helps cool you down. So that's taken into consideration. It takes into consideration radiant heat sources as well. So if you're working near hot process equipment, the evaluation takes that into account. It takes into account clothing impact. So some clothing will hinder evaporation. If the wind can't blow across your skin, you're not going to have the evaporative cooling of sweat, and that may hinder your ability to cool down. ACGH looks at your workload because as the harder you work, the more heat your body generates, and that can have an impact. So they classify work as light, moderate, heavy, or very heavy. They also talk about whether a worker is acclimatized to heat load. So a person who is acclimatized to heat means that their body has adapted, at least temporarily, to the additional heat and makes physiological adjustments to help the body cope with that additional heat. I'll talk a bit more about that as well. So you have to take all these into consideration, as well as the duration of exposure, to determine if a person requires additional break periods as required. Now, the ACGH TLV talks more than just developing break periods, but I'm going to focus on that as part of the evaluation as well. So the ACGH TLV uses a wet bulb globe temperature device, which I've got the picture of here. And it's got three thermometers in it. So the first one being the globe thermometer. There's a thermometer surrounded by a black metal ball. And if there's radiant heat sources, the radiation or UV infrared will hit that black globe. It will heat up and it will raise the temperature of the thermometer inside that globe. You've got a wet bulb thermometer, which has a little container filled with deionized water, and it's got a wick surrounding a thermometer. So the water gets sucked up into that wick. And if it's a very low humidity day, that water is going to evaporate more readily and cool the thermometer down. Likewise, if you've got a lot of wind blowing, it will evaporate that water in that wick and cool that thermometer down as well. Important to note that you have to use deionized water for this. If you use tap water, there's minerals dissolved in that tap water that will then deposit into that wick, and it won't be calibrated accurately, and you're not going to get accurate results. And finally, there's a dry bulb thermometer, which is a regular thermometer. It's basically just measuring the air temperature. And it's got these vanes around it to prevent the sunlight or radiant heat sources from hitting or impacting that thermometer. And it basically will spit out two different measurements. The WIBJIT out or WIBJIT in. WIBJIT out is if you have radiant heat sources or you're working in direct sunlight. And WIBJIT in is if you're working indoors or if you're working outdoors, but you have no direct sunlight exposure. Now, you don't necessarily need to memorize these calculations because this unit will do that calculations internally. You just need to know, do I have a source of radiant heat or not, to know which one you're looking at. And important to note too, when we're talking about chemical exposures, ACGH exposure limits are based on an 8-hour day typically, or 8-hour exposure. But for heat stress, it's based on a 60-minute period. So you're usually looking at breaking down the work into 60-minute period, although it does state that if you have intermittent exposures, you can base it on up to 120 minutes as well. But for the most part, we're looking at a 60-minute period for evaluation of heat stress. So they do have some modern instruments available that don't require the water. They typically just look like they have the globe thermometer. There's other sensors in there, but they have waterless systems now. The picture I've got here is sort of the standard one that's been used, but there are modern ones available that you don't need the water, so you don't have to worry about filling it up. With this unit, you have to keep it level too. If it's not level, you may spill the water. And if you don't have water in that wet bulb thermometer, then it's not going to be measuring accurately as well. So luckily with the technology, they do have alternative options that will provide the same results for you. So this is what we use to take the environmental measurements. We'd set this up. It's going to give us a result in degrees Celsius, although important to note, even though the units are in degrees Celsius, it's not measuring specifically air temperature. So your air temperature may be one measurement. The wet bulb globe temperature reading will be something different. We also want to take adjustments for clothing because if you have certain clothing on, that may impede your body's ability to sweat and lose heat, and that can add an additional heat load onto the worker. ACGH assumes that the typical work uniform is long pants and a long shirt. So if a worker is wearing long pants and a long shirt, you don't need to make any adjustments. And in fact, if your worker is wearing short sleeve shirts and pants, you can actually subtract one from your reading that you got from the environmental. They've got a couple different coveralls there. So if it's a polypropylene coverall, you're adding 0.5 degrees Celsius to the readings you're taking in the environment. If you're wearing a polyolefin coverall, you're adding 1. And you can see the limited use vapor barrier coveralls with a hood. That's more like your hazardous chemical suit. You're adding 11 degrees to your environmental reading. And that's because those don't allow any wind to blow through the suit. It's a chemical resistant suit that doesn't allow for breathing. Plus, then you're encapsulated in the suit, so your body temperature is going to warm it up as well. And that's why there's such a significant adjustment you have to make for that limited vapor barrier coverall. ACGH does say that if you have workers with hard hats or even a full face respirator, there's no addition to the WIBJIT value. And that's because a hard hat and a respirator don't impede airflow around the neck. And most of the cooling you're going to have with wind blowing around you, a lot of it is going to be around your neck. The blood is very close to the skin as it's being pumped to your head and back, and you get a lot of cooling around your neck. So if you're not impeding the airflow around your neck with a hard hat or a respirator, there's no addition that needs to be made for that. Now you also have to look at the worker's work rate. So ACGH classifies it as light, moderate, heavy, or very heavy. You can see in this table that I've copied from the TLV booklet, they have the metabolic rate in watts that the body generates during these categories. They do have some calculations in the TLV that you can go through and actually calculate the amount of watts based on what they're doing, or you can use the examples they have to sort of evaluate what the worker's work rate would be. So light work would be example, you're sitting doing some manual work with your hands and arms. Drivers would be doing light work. You could be standing doing some light work with periodic walking. For example, you're standing at a station, you're picking parts coming out of a machine, then you've got to take those parts, drop them off somewhere else near you, and then come back waiting for the next part. That would be considered light work. Some examples they have are welding, operating a crane or driving a truck, or using a table saw are examples of light work. And that's typically work that you could perform for a sustained period of time without much effort. Moderate work is sustained, moderate hand and arm work, moderate arm and leg work, or trunk work. There might be some light pushing and pulling involved, normal walking. And these are typically activities that can be performed for sustained period of time with some effort. The examples they give are laying brick, hammering nails, raking asphalt, or sanding drywall. So those are examples of some moderate work activities. Heavy work is intense arm and truck work. That can include things like carrying heavy objects, shoveling material, manually sawing. So if you think you're taking a saw and you're cutting wood with a handsaw, pushing or pulling heavy loads, walking at a very fast pace. And this is typically work that you would really only perform for about 30 minutes before you start to get tired, whether there's heat involved or not, and you'd probably want to take a break. Where very heavy work is intense activity or fast-paced work, very close to your maximum output. Typically something you'd only be able to perform for 15 minutes or so without taking a break. They include examples like shoveling wet sand. So if you're shoveling sand, that might be a heavy workload, but if it's wet sand, making it very heavy, that's going to be a very heavy workload or lifting heavy objects. Now, having said that, with a different work class, ACGH does note that there is a tendency to overestimate the metabolic demands of a job for two main reasons. Number one, the first is that we often focus on the peak demands of a job task, and we ignore the lower demands or even recovery periods within that task that are not accounted for. So, my example of a worker pulling parts out of the machine and putting them in the shipping container, then coming back and maybe adding the parts ready for the next one. If that part they're pulling out is heavy, you may look at that and say, well, that's a heavy task because it's a heavy part and he's carrying it to the shipping station and then coming back, but you're not really focused on the period of time that that worker's waiting for the machine to cycle through or the light tasks that the worker's doing for setting up the next part. You may just look at that one task and say it's heavy when if you're to look at the whole job as in its entirety, you may only classify that as a light task, even though that one portion of it may be more demanding. The second part is the role of static work. So isometric muscle contractions. So for example, you've got to grip something. Uh, that always causes a greater physiological strain, but without contributing to a metabolic demand. So if you're gripping something tightly, your forearms are working, but your forearms aren't generating a lot of heat for your body. Versus if you're picking up heavy objects, you're using your legs, your back, your arms, your stomach, you're using a lot more muscles, and that's actually generating a lot more metabolic heat than gripping something. So we often see people are doing something that requires them to grip something or move something, and the perception is that you're generating more metabolic heat and it's a higher class than it actually is. The other thing I alluded to was acclimatization, so physiological adaptation to heat exposure. A worker will become acclimatized to heat if they've had at least 2 continuous hours of heat exposure for 5 of the last 7 days or 10 of the last 14 days. So typically 1 or 2 weeks of heat exposure where they're exposed to heat every day of their working week, they will start to become acclimatized. You can also lose acclimatization fairly quickly. So if you have 4 days of no exposure, you start to lose the acclimatization, and it's completely lost within 3 weeks of no heat exposure. So why is this a concern? Well, you have workers that are acclimatized to heat, but then they go on vacation somewhere, and maybe they're not going to the Caribbean, maybe they're going to somewhere like Iceland where it's not hot. They're going to lose that acclimatization, and when they come back, they may not be able to jump into their job activities and do the same work that everyone else is doing who's also acclimatized because they've lost that acclimatization and they're more susceptible to exposure to heat. Similarly, if you have new workers, they may be more susceptible to the exposure to heat as well, and you may need to take that into consideration. And that's why the ACGH has classified workers as either acclimatized or non-acclimatized. Workers that are also performing heavy or moderate work will become acclimatized faster than someone who's performing light work as well. And the Ministry of Labor has reported that in Ontario, it's very rare for workers to become acclimatized to heat waves because heat waves don't generally last long enough in Ontario. We may get a 1 week heat wave and people may start to become acclimatized near the end of the heat wave. Then the heat wave disappears and they're going to lose any impact and not really gain any impact. So if your exposure to heat stress is due to heat waves, you're likely not going to be able to assume that your workers are acclimatized. They will be considered unacclimatized to heat. Versus if you have someone working next to a furnace all year, they're working next to that furnace, whether it be in the winter or the summertime, they could possibly be acclimatized to the heat because they're exposed to that heat all the time. Um, so what does that mean to be acclimatized? Well, typically about 80% of your muscle's energy is converted to heat. So as you're moving, that gets generated into heat. But when you become acclimatized, you have physiological adaptations. So you have an increased level of sweat output. So more sweat means more cooling from natural ability. You also start to sweat sooner. So if you have two people working side by side, one's acclimatized and one's not, the acclimatized person will start to sweat before the other person and they'll sweat more. They'll also have a better quality sweat as well. So their sweat doesn't contain as many electrolytes. They're not going to lose as many of those electrolytes as a person who's unacclimatized. An acclimatized person will also have increased blood flow to the skin surface to help drive off some of that heat. They'll have a reduced core body temperature as well. They will have a reduced heart rate. Their blood will have more plasma in it, so it'll be not quite as thick or thinner, allowing them to sweat more as well. And there's other modifications that the body does when it's exposed to heat for long periods of time as well. But those are the most significant ones. So now let's look at the HGH TLV. So we've taken environmental measurements. We've looked at the work rate of the worker. We've made adjustments for clothing. We've determined whether they're acclimatized or unacclimatized. Now we can look at the table they've got, and this is taken right from the HGH TLV booklet to know whether additional breaks should be provided for those workers. Now I did note that in the Ministry of Labor their proposal, they only included the acclimatized workers. I'm assuming that was just to make the table easier to see, and I'm assuming that if this does become a heat stress regulation, that they will include provisions for both acclimatized and unacclimatized workers, especially considering most Ontario workers will not be acclimatized to heat waves, which is one of the big concerns for heat exposure in Ontario. So I've got an example here. We've got a worker in a manufacturing area. They're working near a hot oven, so there's a source of radiant heat. And we're going to consider them acclimatized because they work around this oven all year round. Their work rate is considered moderate, so there's some heavy lifting and moving materials around, and it's a dusty environment. So they've got a polypropylene coverall on. They're not wearing the hood, but they've got that over top of their regular clothing. So in this case, because they're wearing a polypropylene coverall, we're going to add 0.5 degrees Celsius to the WIBJIT reading we have. And in this case, we take our WIBJIT monitor out there in the environment the worker's working in, and we're getting a reading of 28.5 degrees Celsius. So let's look at the ACGH table and see what that tells us. So moderate work rate with an adjusted WIBJIT value of 29, so that's the 28.5 we measured, plus the 0.5 for the coveralls. That falls into the 50 to 75% work rest schedule for an acclimatized moderate worker. So that falls right in here. So that means that for that worker, every hour they should be spending at least 15 minutes on a break period because of that heat. Now, if the HGH also, their TLV guidelines here assume that the break periods are taken in the work area. So in this case, after 45 minutes of work, the supervisor comes over and says, okay, we're taking a heat break now. Everyone puts down their tools and they sit in their work area for 15 minutes before they go back to work. And now, if you have a rest area in an air-conditioned area, you can take a time-weighted average approach to reduce the break time. So I'll go through one of those examples, and sorry about this, there is some math involved with this example here, but we're going to use the same example, moderate work rate with an adjusted WIBJIT reading of 29, so the 28.5 we measured, plus the 0.5 for the clothing. But in this case, the rest area has a WIBJIT reading of 22, so quite a bit cooler. So we can use a time-weighted average approach where the time-weighted average results equal the WIBJIT reading, adjusted WIBJIT reading in the work area times the time they're in that work area, plus the WIBJIT reading of the rest area, multiplied by the time they're in the rest area. And we're dividing all of this by 60 minutes because the TLV is based on a 60-minute period. Now, for the moderate workload, in order to get them to 100%, we have to get that total value, the time-weighted average total, to 28 or less. So if we add 28 as the amount that we want, the WIBJIT reading we measured plus the adjusted clothing is 29. We don't know what the work time is, where that's one of the things we're trying to calculate. We're adding that to 22 degrees, the measurement in the rest area times the rest time. Again, we're not sure what the rest time is yet, and divided by 60. So we've got two unknowns in this equation, but we do know that the work time plus the rest time equals 60 minutes. So if we calculate the rest time equals 60, or the work time equals 60 minutes minus the rest time, and we multiply both sides by 60 minutes, we can rearrange this equation to get the 28 that we want, multiplied by the 60 minutes equals the 29 we measured, the adjusted measurement. And that's what the work time will be, 60 minutes minus whatever the rest time is, plus the 22. We do that calculation and it works out to be 8.5 minutes of rest time that's required. So we've effectively reduced the amount of rest time needed from 15 minutes to 8.5 minutes by having that worker rest in an air-conditioned area versus having them rest in their hot work environment. Um, Now, it's more comforting for the worker to rest in the work area and may increase productivity as well. One example I could think of that I've encountered was working at a copper smelter where they had their giant furnace that has the molten metal in it. They can't turn the furnace off to repair it because the metal would solidify, so that would wreck their furnace. And the bricks on the top of the furnace need to be replaced every once in a while because over time the heat degrades them, but it's very, very hot on top there. In fact, if you were on top of the oven and you stood too long in the same place, your shoes begin to melt. And when we put our Wibjet monitor on the railing to take measurements, it started to melt to the railing as well. So very hot environment. We did this time weighted average calculation, and it sort of worked out to the opposite of this, where the workers could only spend 9 minutes working on top of the oven as long as they spent the other 51 minutes in their air-conditioned lunchroom, which was very cold. When we looked at the initial monitoring, the Wibjet value was so high that it was off the charts. It basically said you can't do any work in this area because you're exceeding the Wibjet value. So the only way for them to be able to provide the workers up in this area was to have them work to rest in an air-conditioned area. So they had 4 crews. You'd basically work for 9 minutes, go back to the lunchroom, send the next crew out. They'd work for 9 minutes, and they'd keep doing that um, until the work was done. But very hot environment in that case where they had to use this time weighted average approach. Also important to note too, if this was a non-acclimatized worker, um, they would have to spend 45 minutes in the rest area. And if we had them rest in the cool area, that rest time would be reduced from 45 minutes to 34 minutes as well. So you can have significant impact by having them rest in a cooler area versus their work environment. Now let's talk about the OCal method. I know some of you are familiar with this or have done this measurement. It's um, It's an easier method to use because it relies really only on the environmental side on 2 measurements. You're measuring the humidity level and the temperature level to calculate the humidex. If you don't know the humidex level, I mean, you can use things like Environment Canada to get the humidex level of that day, but you have to be aware that those measurements are usually taken at the airport and they may not necessarily be representative of what your workers are exposed to. So it's always best to still take measurements, whether you're taking humidex measurements or humidity and temperature. You can go to the OCal website and they do have a calculator there where you can enter the temperature and humidity and it will spit out what the humidex value is. Humidex value is sort of a representation of what it feels like. So if it's a 30-degree temperature and there's 0% humidity, it's going to feel like 30% or 30 degrees. But if it's a 30-degree day and you're closer to 80% humidity, it's going to feel a lot warmer. And the humidex value will indicate a number higher than 30 degrees. So this method is very good if you're working outdoors, as an example. But they do have provisions in there. So for example, for clothing, so there's clothing adjustments, and they're different than the ACGH because it's a different measurement scale. So for example, if you're wearing cotton overalls, you would add 5 degrees to your humidex reading. If you're wearing gloves and a hard hat, you would add 1 or 2. If there's a radiant source of heat, you're going to add 2 or 3 degrees as well. So working near a hot oven, you may add 3 degrees to your reading. If you're working outside, you're going to add 2 or 3, depending on how cloudy it is on that day, as an example. Um, and then you can look at the table they've got here. Humidex 1 would be for unacclimatized workers. Humidex 2 would be for the acclimatized workers who have been working around heat sources. They do state that if you have a humidex exposure above 45, they suggest that you use the ACGH TLV because it takes into account more things thoroughly than this method may. So let's take a look at this example. The OCal takes into account environmental heat, measures the air temperature and humidity to calculate the humidex values, and there are adjustments made for radiant heat sources. Although the adjustments are sort of general, they're not specific for the measurements. There is a clothing impact adjustment. So OCal recognizes that clothing may hinder evaporation, and you have to take that into consideration. They consider whether acclimatized workers or unacclimatized workers are being exposed. And you take these all into account to again determine if additional breaks are required. So here's an example. We have workers outdoors. They're working in sunlight, but it's mostly a cloudy day. So we're going to add 2 degrees to our reading. They're considered unacclimatized to heat because maybe it's a heat wave that's come through, and they're doing moderate physical activity as well. This OCal is based on assumes that the workers are doing moderate physical activity as well. So it doesn't take into account the workload as well as ACJH. Um, and in this example, the worker is also wearing cotton coveralls. So we're going to add 5 degrees to our Humidex reading. So we measure the Humidex and it's 32. That is an adjusted Humidex reading of 39 because we're adding 2 for the sun and we're adding 5 for the clothing. So adjusted Humidex of 39. We're looking at Humidex 1 because it's unacclimatized worker, and 39 falls into this category here, meaning that the worker has to be provided 15 minutes of break time per hour. And it also has some other comments in there too, like provide adequate drinking water. The worker should drink at least 1 cup of water every 20 minutes, as an example. Now, if we were looking at an acclimatized worker of the same reading and the same clothing, that 39 degrees actually falls into the continuous work. Additional breaks aren't required for that. So you can see the impact of being acclimatized versus unacclimatized. If you had acclimatized workers, they may not need to take additional breaks. But if you have a new worker or a worker returning from vacation, they're probably going to have to take at least 15 minutes of break per hour in the same conditions. So we've looked at why we have to consider heat stress. We've looked at the impact or what we think regulatory conditions may state we need. We've looked at a couple different measurement techniques as well, but let's look at a heat stress program. Recommendation is if heat stress is a concern and you need to take action to control heat stress, you should have a program in place that talks about heat stress management in your workplace. So the Ministry of Labor proposal did indicate that measures and procedures beyond engineering controls to control heat exposure must be in writing and developed in consultation with the Joint Health and Safety Committee. So that suggests that a heat stress program or a hot weather plan should be developed. If you do have a hot weather plan, because maybe environmental heat outside is the only concern, or even if you're working indoors, but the environmental heat is the concern, then those hot weather plans should be in place between May 1st and September 30th. Those are typically when we experience hot weather. Well, this year, I think we could probably push that to June. You also want to consider your working population as well. So elderly workers, new workers, workers that might be overweight or on certain medication may be more susceptible as well. And the ministry does state that a hot weather plan is basically a simplified heat stress control program. So the plan should include the following items. First of all, the roles and responsibilities. So who's taking the measurements? Who's calibrating the equipment? Who's providing the drinking water? Who's going to inform the workers that they need to take additional breaks? And there should be employer buy-in on that as well. You should talk about training. That's very important. Training should include what the definition of heat stress is, the signs and symptoms of exposure to heat, the importance of reporting the symptoms, when, how, why to take breaks, recognition, assessment of heat stress and controls. And the training should be done before workers are exposed to heat. So providing that training in the middle of August isn't going to do the workers much good if they've already been exposed to heat and could have been at danger. So typically training is provided in the spring. You should talk about the monitoring methods. So how you're going to monitor, what methods you're going to use, what evaluation you're going to use, whether that be ACGH TLV using WibJet or the OCal method using Humidex should be discussed in your program. It should talk about how, when, why, and how often you're going to monitor. So, maybe you have to take measurements multiple points during the day as the day gets warmer. Where are you going to take those measurements and how and who are going to take those? You want to talk about the response. So are you providing additional rest periods? What other controls are going to be put in place? Engineering, administrative, or personal protective equipment? The program should mention that you're going to provide cool drinking water to the workers near the work area. There should be emergency response. What happens if someone actually gets sick from being exposed to heat? Is there going to be first aid? How's that going to be provided? Are you doing medical monitoring? Record keeping is a big part too. So anytime you're out there taking measurements, this should be recorded, provided to the Joint Health and Safety Committee or posted, and it should be kept as well. So if the Ministry of Labor shows up and says, what are you doing for heat stress? You can provide them your heat stress program or booklet that you've got that shows the measurements, shows records of who's been trained and when, and all the information that's needed. And there should be a periodic review. So at least every year, the program should be reviewed to make sure it's working properly. And if there are some pitfalls in your program, then what you've done to adjust that program to account for that. So let's look at control methods, because basically that's what we ultimately want to do is control the heat stress. General control methods include development of a heat stress plan and program that makes sure everyone is informed on what to do. Worker training, let people know about the hazards, recognition of the hazards, and what to do in case they are experiencing heat stress. Provision of cool drinking water. Staying hydrated is one of the best ways to prevent heat stress. First aid response. So if someone does get ill, what are you going to do? Use of a buddy system, especially if you have a worker working in a very hot environment. It's not ideal to have them working alone because of the inability to sometimes self-recognize the symptoms. Heat stress evaluation, so taking measurements out there, including additional break periods if required. Personal monitoring devices could be a control method. So I've seen devices that measure the quantity and quality of sweat. So it measures the volume of sweat coming out of a person as well as how much salt is in there, and it will send alerts to the workers saying, "Hey, you need to drink more water." I've seen devices that measure heart rate and temperature. Some of them you stick in the worker's ear and they measure temperature. Various degrees of quality of instrumentation and use for that, but they are available. Some more specific controls like engineering and administrative controls and personal protective equipment, mechanical aids. So if you've got a worker that's got to lift heavy parts, having them bend over and lift those parts in a warm environment is just going to add to their metabolic heat load. So if you have a lifting device that raises those device up so they don't have to lift as that container gets empty, that's going to help them. Lifting devices so they're not actually bearing the brunt of that heavy object will help. Insulating hot process equipment or using heat shields. So if you have workers working in a hot environment because there's hot pipes running through the area, well, insulating those pipes will help reduce their radiant heat sources. I've seen in steel making facilities where they use heat shields and they stand beside them. There's a little window where they're standing beside this heat shield, and it significantly reduces the amount of radiant heat that reaches them. If you're working indoors and you've got equipment that generates heat, exhausting that hot air from that equipment outdoors may help alleviate some of the heat stress for those workers. Air conditioning, that's obviously a great way, or dehumidification will help reduce heat. Comfort fans can be used as well. Increasing the air movement over a worker's skin will help them cool. However, if the air temperature is 35 degrees or more, comfort fans won't provide any help. In fact, it's more like a convection oven blowing hot air over a worker. So comfort fans will only work up to 34 degrees. Anything above that is not going to be helpful. Rescheduling work for different parts of the day. So instead of doing the hot work at 2 in the afternoon, reschedule that work to 7 in the morning, or even do it on a night shift when it's a lot cooler. Providing shade to escape direct sunlight for outdoor workers. Worker rotation. So instead of having one worker work in a hot environment all day, you split it up. So maybe 4 people are working in there, but they're only spending at maximum 2 hours a day in that hot environment. And personal protective equipment, cooling vests, radiant clothing. So the silverized clothing that prevents the radiant heat from getting to the worker, or cooling bandanas, neck shades. There's lots of different PPE The one difficulty I've seen with personal protective equipment that are designed to cool the worker, most of them that well, all of them that I've seen don't provide you with WibJet or Humidex adjustment. So we see adjustments for wearing clothing that may increase the heat load, but I have not to date seen any adjustments that say if you're wearing a cooling vest, you can subtract so much from your WibJet value or your Humidex value, or if you're wearing a radiant heat clothing, how much impact that will have on a WibJet reading. So I think that's a sort of a gap in a lot of the personal protective equipment. They've developed this, they work well, but how well they work in terms of the evaluation is a little bit difficult to evaluate. Some other considerations, you want to avoid alcohol or caffeinated beverages while working in hot environments. They are both diuretics, meaning that you will end up urinating out more liquid than you take in. Caffeine can help keep the worker awake, but in hot environments, it may be more detrimental to them. Drinking water or fluid replacement fluids are always the best option. You want to avoid eating a large meal before working in hot environments. If you eat a hot meal, all your blood is going to be directed to your GI tract instead of to your skin to help lose the heat. Wear light colored clothing that allows for sweat evaporation if possible. So you have things like those Under Armour garments that you may use for athletic or working out. They help get the sweat available for sweating, and they can help you reduce your heat. And use sunscreen or cover your head if you're working outdoors in sunlight. Again, I didn't really talk about the cancer risks, but that's a concern you have to think about if you have workers in outdoor environments. And workers, if they're on certain medications, they should check with their doctor to determine the impact of that. Some medications may alter their ability to lose heat, sweat, things like that. So a doctor may want to evaluate that if they're working in a hot environment. So what are the next steps? So even though we don't have a specific heat stress regulation effect, we still have to control a worker's exposure to prevent heat stress. ACGH is the industry standard, especially if there's a source of radiant heat or if you're working in very hot environments. But there are methods available to control exposures, and the ministry would consider things like the OCAL method acceptable to evaluate heat stress in your workplace. If heat stress is a concern at your workplace, you should really consider developing a heat stress program or plan so that you talk about the management of heat stress in your workplace and you've got it documented as well. Oh, any questions out there? No questions?
Don't see anything in the questions chat right now, and no one has their hand up.
Okay, I'll put my email in the chat. If anyone does have questions or think of questions afterwards, feel free to send me an email and I'll do my best to answer that. And Jose, you mentioned that we were going to be posting this as well.
That is correct.
Okay,
So what we will do is we typically when the session is actually done, we do create a vlog on our website, and it'll be under our I believe it's our what to do. We just got a new website, so I just need to know where that is. But we also do put it on all our social channels. So if anyone is following LinkedIn, Facebook, Instagram, and X, we all have them there as well, promoting it directly to there. But if you go on to our website, within where we put our normal blogs, you will see that within the next few days or so.
great. Okay. Well, thanks everyone. I hope you got some good information out of this, and we'll sort of keep our fingers crossed when it comes to the heat stress regulation. I would anticipate next year would be the earliest it will come out, if one does come out. But regardless, we still have to control heat stress. So thanks everyone for attending.